Good morning. I'm Jennifer Schenker, founder and editor-in-chief of The Innovator, a global publication about the tech sector, and I'm very pleased to be moderating the panel on powering intelligence. AI is useful for optimizing our energy ecosystem, but it also needs a lot of energy. And right now, the demand side dominates the AI discussion because it requires gigawatt-scale power. Questions include whether the AI data centers will use clean electrons on the front end, whether the grid will be sufficient, what the water footprint will be, and whether we can build them fast enough, and what the cost implications will be for consumers. This panel will examine how new approaches to geothermal, fission, and fusion could help, and examine why AI providers are already committing to offtake agreements with these next generation energy providers. So let me introduce our esteemed panelists. All the way at the end here, we have Francesco Sciortino, an Italian physicist who came back to Europe to work for the Max Planck Institute for Plasma Physics after earning a PhD at MIT. He is CEO of Proxima, the Institute's first commercial company. We have Guido Houben, head of Germany at Transmutex, a Swiss scale-up that was named a World Economic Forum Tech Pioneer in 2023. The company uses particle accelerators to transmute long-lived nuclear waste into carbon-free energy. And last but not least, Tony Pink, an expert on geothermal energy. He's director owner of Pink Granite Consulting and CTO of UK-based Eden Geothermal. So let's start with fusion, which is a hot topic in Davos this year. Francesco will be speaking on a panel about fusion at the World Economic Forum's annual meeting. So just to set the stage here a little bit, fusion, the process that powers the sun and the stars, could provide a nearly limitless source of energy without producing harmful carbon emissions or long-lived waste. The world's first commercial facility would mark the dawn of a new era of energy. The promise has excited scientists since the 1950s. The holy grail, the ability to produce more fusion energy than is needed to create it, has remained elusive, but we're getting a lot closer. And the US Department of Energy's new fusion roadmap, which was published in October, outlines how it expects the technology to become part of the US's energy mix by the early 2030s. And one of the clearest signs that fusion is moving from a scientific experiment to a commercial reality is that the IAEA World Fusion Outlook 2025 for the first time includes global modeling of fusion energy deployment. If we manage to produce fusion at the lowest capital cost, it could reach a share of electricity generation of up to 50% by 2100. Now, governments see fusion as being very strategic in the same way as AI and quantum computing. And the race is on to see who is going to get there first. There's at least 45 companies working to commercialize fusion energy around the world, and the IAEA reports that more than 160 fusion facilities are now operational, under construction, or planned. Now, Max Planck Institute, the IPP, has been at the forefront of fusion research for 60 years, but the US has been outpacing Europe in the creation of commercial fusion companies. Boston-based Commonwealth Fusion System is a case in point. It's on track to bring online its first grid-scale commercial fusion power plant in Virginia in the early 2030s. And it's already secured a conditional user permit and offtake agreements from Google and from global energy company Eni, with Eni's offer alone valued at over $1 billion. Both Google and Eni are also investors in CFS, and CFS is competing with Helion, another fusion energy company in the US, building what it says will be the first commercial plant in the US. And it's being backed by OpenAI's Sam Altman. And Microsoft has already signed up as an offtake partner. So Francisco, against that whole backdrop, tell us about Proxima's trajectory and, how will Europe catch up with US and China?
As you said, more than $10 billion now invested in private fusion companies worldwide. You have to balance that with also the effort that has been going on in the public sector. Fusion is very much at that interface between transferring knowledge from national labs into private companies. In the domain of magnetic confinement fusion, so the use of magnets to confine hot ionized matter and try to build a star in a laboratory, that's one place where Europe can really kick ahead. On the public side, as you mentioned, the Max Planck is an historical institution. In the subdomain where Proxima operates, it's a concept called a QI stellarator. I used to work on the concept that CFS in Boston has been building up on, and I shifted my focus to QI stellarators. And that's where Germany and Europe are objectively far ahead. We spun out from the institute in 2023, so 3 years ago. Now we're about 130 people, raised about 200 million euros. And of course, there is a lot to do. You don't quite build one of these devices with 200 million euros. We are talking about energy infrastructure. We're looking at billions needed to actually scale this up. That's the value of gigawatts. I think that's something that connects all new energy generation methods. We need to think at scale. Fusion does lend itself to thinking about how do you actually change an entire energy ecosystem, complementing renewables. You need to go step by step. Our game needs to be to demonstrate not only performance, not just net energy gain, but do it in steady state, so continuous operation. Do that at the same time with a system that is stable. And all of those things we're trying to knock out as Proxima Fusion in the early 2030s. That's the alpha device. We have an exciting announcement coming out in hopefully just a couple of weeks. And then we need a first of a kind. And that first of a kind for us, the objective is second half of the 2030s. And so step by step, working in public-private partnerships, we think Europe can absolutely kick its way to the leadership.
Okay, thank you. So let's now turn to nuclear power, which was once regarded as dangerous and an undesirable source of energy, was definitely not one of the favorites here in Germany, but it's increasingly being seen as a way to supplement renewables, gain energy sovereignty, and power data centers. Now, earlier this month, nuclear technology company TerraPower and Meta announced a new agreement to build up to 8 advanced nuclear reactors supporting Meta's growing energy needs. Launched in 2008 by Bill Gates and Nathan Myhrvold, TerraPower is a nuclear innovation company aiming at creating technologies to provide safe, affordable, and abundant carbon-free energy. And Bill Gates serves as the chair of their board. Europe has its own crop of new nuclear companies, including Nucleo and Transmutex, both fueled by reprocessed nuclear waste. Paris-headquartered Nucleo has agreed with Oklo, a California-based nuclear tech firm backed by OpenAI CEO Sam Altman, to jointly build advanced fuel fabrication and manufacturing infrastructure in the United States. The US is clearly racing ahead on nuclear as well. So where does that leave Europe? Nuclear was discontinued in Germany, but it's now getting a second look. Guido, tell us about Transmutex study with Sprind, the German Innovation Authority, and where you are on your trajectory.
Thank you very much. Can I have a mic?
Yep.
Thank you. Let me start out with nuclear. Nuclear fusion is nuclear, and then we have nuclear fission. That's the old traditional nuclear. And then in between, we have nuclear transmutation. So Germany never left nuclear. We're just switching, and we're coming to nuclear medicine maybe later on. So just to say, we're all nuclear. To some degree, also geothermal. We'll get to that. Now, to your question. Transmutation, if you allow me to say that, you talked about reprocessing waste. What we want to do is transmute nuclear waste, existing waste, which we also have in Germany at the various sites of the former nuclear power plants, into clean energy. Now, how would we like to do that? First, you, as a good German, you separate the waste. You take a look at the waste and you find out that you can separate it with certain processes in waste streams, and 90% of that you can recycle. It's precious gases, precious metals. Some parts of it can be used as medical radioisotopes or for the aerospace industry. And then 10% is ugly material that so far we have no use for. And so that's the part that is radioactive for 1 million years, up to 1 million years. And this is what we would like to get rid of. How do we do that? In our case, we're working on a high-power particle accelerator. And so we shoot a proton beam basically on the waste, and then it doesn't disappear, but it transforms into something that is only radioactive for about 1,000 years and not 1 million years. And so if you followed the Endlagerdebatte here in Germany, then you know that this is a big advantage if you have waste which is actually only 1,000 years radioactive and only 10% of that. Now, you mentioned the SPRINT study, the Federal Agency for Breakthrough Innovations, and we said, look, the Germans are notoriously skeptical about nuclear, anything nuclear, even to some degree fusion. So if we want to do something here, we have to have a study done by people who Germans trust. And so we asked the Technical University of Munich and TÜV North and others to do an implementation study. How would it actually look like if we built one of our plants here in Bavaria on one of the previous sites of the nuclear power plants? Because as for you, it's very important. You'll never get anything done on the green field in Germany. So you have to reuse existing sites. That makes it much easier in terms of having a grid, having infrastructure, in our case, having the waste on the site. There are so many reasons why you would use such a site. And so we did that study, published it last year, and it turns out from an economical, legal, safety perspective, it's absolutely adamant that you use one of these existing sites in Bavaria, where you have a very benevolent, I would say, very positive environment, very positive ecosystem. We have 3, Grafenrheinfeld near Würzburg, Isar 2, of course, Isar 1, 2, and then Gundremmingen west of Munich. So on one of 3 sites, I think we're going to build, maybe together. Right now, this is where I would leave it, and the study was so successful that Sprint said we're going to invest 7 million for now, and then maybe later more once we start building.
So to sum up, you're saying, okay, our approach, our technology approach allows the reuse of existing radioactive waste to fuel the new generation of nuclear power. It can also, some of it can be repurposed for medical isotopes, and the small amount, the 10% that cannot be reused, this you can reduce from 1 million years to 1,000, and that Europe has a chance potentially to leapfrog ahead by reusing existing nuclear power plants. Is that a fair summary?
Exactly, that's about it. Yeah.
Okay, great. Now let's turn to geothermal and look at, thank you for your patience, Tony. So, you know, geothermal is of course not new, and the Greater Paris area in France has been using geothermal energy for heating since 1969. And the airports, Charles de Gaulle and Orly, are powered by it. And it's being piloted for district heating all across Europe, including here in Munich. Germany is expected to spend more than 1.5 billion on geothermal by 2030. And the only country to install more capacity between now and 2030 will be the Netherlands. However, geothermal energy currently meets less than 1% of global energy demand. Its use is concentrated in only a few countries, but it could meet up to 15% of global electricity demand by 2030. Now, Tony, you are advisor to 2 cutting-edge geothermal projects, one in the US and one in the UK. Please tell us why future data centers are likely to be built next to next-gen geothermal sites.
Cool, thanks, Jennifer. So, it's an absolute pleasure to be here as a underperforming geologist with two physicists at I'm truly humbled. So, but there is a moment in time, and some of the awe-inspiring presentations I saw this morning about this moment in time. There is a moment in time for geothermal, the Earth's nuclear reactor. And what has happened is geothermal's greatest problem is, in many cases, the energy is not where you need it. It's on the Pacific Rim, it's on a volcano, it's really challenging to get to. But with the drive into this enormous energy consumption that's coming from data centers, yeah, and the future projection of that, what is very good is that bits and bytes are unbelievably easy to transfer. So now, if we create a gigawatt geothermal power plant on a volcano in Oregon, we can put the data center on the high desert up there and power the data center, rather than trying to squeeze it into the wrong place. So geothermal is seeing a renaissance of the flow of capital from Google, Meta, the large data providers. How can we become an enabler of society and not a pariah on society by consuming all this energy? So the data center geothermal world is really good. The example in UK is even better in many ways, because it has driven the data center provider to look at creating environmentally friendly data centers. So this little startup called Black Cat, BLAQ, they're creating geodesic domes that sort of self-cool from the sea breeze coming in off the ocean. And then all the power for that is coming from the geothermal well that's right next to the data center. So we've moved the data center to the well. And this pull is really helping us. On the push, a number of really transformative technologies have come out in the last 5 years, which mean that we can drill very hard basement rock, where we would have drilled deep under Munich at 5 meters an hour. That is now 35 meters an hour. So the economics of geothermal, the levelized cost of electricity is plummeting as we're getting this pull from data centers.
Okay, thank you very much. Now, Francesco and Guido, why are we not seeing offtake agreements from the AI providers for fission and fusion here in Europe?
Because the hyperscalers are American, so they're going to look at the US first. That makes a lot of sense. We are building data centers in Europe, so that will come here as well. I think where Europe needs to play its cards differently is in bringing the industrial power where innovation is actually needed. Energy is one of those easy fields where you know that the market is basically infinite. So none of our companies in any way have a market that is saturated. That's a good thing. When you go and raise venture capital, one wants to show that the market is accessible. And the question for much of all the energy-related tech companies is feasibility. It's how fast you can deploy. Can you get to the point where your limitation is not some funny, boring narrative, but instead it's how fast can you pour concrete? How far can you go with metal? That's why Europe needs to get more going. It needs the industrial giants, those that were founded 150 years ago, to realize that energy innovation is sort of back in town, that we won't necessarily be using the fossil fuels in the same way for a long time. Even in established energy fields like nuclear fission, that the innovation needs to click in. Fusion is a completely different bunch of technology stack, let's say. But the hyperscalers are relevant, to go back to your point. They are looking at all new energy sources, whether in geothermal, fission, or fusion. In Europe, we need to sort of figure out what are our actual angles of strength, technically, as an ecosystem, and governments. Energy is always set through government policy to a significant extent. You cannot quite detach these things. In fusion, worth me mentioning, it's one of the topics that the Chancellor Merz has identified as one of the key 6 domains for the high-tech agenda. So we're very excited to have that kind of public-private partnership. But we need to sort of keep up the speed because the hyperscalers are hungry, not just them.
I would also see two major differences between, let's say, the US and Europe. Marketing is very important in the US, and it is to a much less degree here in Europe. And these agreements that you see between the Googles, the Metas, etc., and some companies who may or may not in 10 years produce energy or be out of business, for me that's a marketing gag to raise hype on both sides, which is good so that they can fundraise, but is something that I would say is contrary to how Europeans act. I think we're much more grounded in reality, and the idea to just do something because it helps you fundraising is probably not very close to our culture.
Everything is legit as long as people build,
Exactly.
right? As if it's only PR, it's not quite good enough.
And then the second difference is we're very densely populated in Europe. You're not going to build, be that a transmutation plant, a fission power plant, or a fusion power plant next to Frankfurt just because that's where the data centers are. It's just not going to happen. You may do that in Washington State, maybe, but not in Europe. So you build a power plant on an existing site, for example, or maybe on the greenfield somewhere, and that's how you produce energy, and that energy will be used by everyone else. The idea that some Google of Europe, Northvolt or whoever, would buy an acre next to their data center in the Taunus area and put 2 billion in it to build their private nuclear power plant, it's just absurd in Europe. It's not going to work.
Okay, thanks. All right, so we are going to have to race now because we're racing against the clock. But I do want to make the point that we can't build fast enough alternative forms of energy. In addition to consuming power, AI can actually accelerate fusion and fission. And new technologies, as you mentioned, are helping accelerate geothermal. So can we just 1 minute talk about how AI is helping accelerate fusion and fission, and then we're going to go into our last question.
So in our case, the device, if you Google what W7X looks like, that's the stellarator in northern Germany. It's a real device, it's not a drawing. You immediately see that this is a very twisty geometry. It's a problem that is computationally driven. So the ability to use, back in 20 years ago, supercomputers now has translated into a quest for the greatest design integration that you can get, the greatest automation, the best data structures, and that obviously lends itself to then having a system that is driving automated decisions. In other words, that's computational statistics, or if you like, AI. And all of that is accelerating in a number of domain-specific ways. And at the same time, I was just discussing last night with somebody, looking at problems, especially in deep tech, where the limit has been how fast we can actually code up some description of a complex system. That is affecting all of deep tech. I think it's a good reason, the speed at which Claude Code is structuring our designs. It's something that should make people bullish about the things that have looked like more than a decade away, and they're likely not.
Yeah. I'd say it's so utterly important that we work on this. Even fusion. I mean, some people say fusion, oh my God, this is very far away and maybe it will never happen. Who cares? It's not important. Even if it doesn't happen, there are so many things that come out of it. And of course, you and I, and you probably too, we have our little staff who work on very specific problems for which we use AI. And sometimes, more often than not, these spill out into other projects. Like we developed an AI tool to keep our accelerator steady. And that's an enormous tool, and everybody tells us, wow, this is gigantic. You can use this for a lot of other industrial applications to steer this with AI instead of human operators. And I'm sure that we all have tens of those examples where our little teams develop something which will just bring us ahead.
Okay, thank you. So let's move to the last question. So Look, fusion startups in Europe like Proxima, Novatron, Marvel Fusion, and Renaissance, they've raised tens or hundreds of millions, while the US commercial upstarts like Helion have raised $1 billion and CFS has raised over $3 billion. China is also pouring money into fusion, making it a #1 priority. And Europe's next-gen energy companies clearly need to find a way to raise more money, but what else needs to change for Europe to keep pace with the US and China and ensure that its own next-gen energy companies will power its AI? So let me start with you, Tony.
Yeah, I guess the biggest challenge I've seen in the differential, so I recently returned from living in the US for 18 years, is the process, the planning process. So in the US, to start a geothermal project, to go from idea to drilling is probably only 2 years. In Britain, that planning process, in Britain and in Europe, that planning process is 2, 4, 6 years. We need to shorten that back. And by shortening that, we will, and we can do it, yeah. I think we can prove that it's safe, reliable, environmentally friendly, and I think we'll accelerate that process. I think that's the biggest one.
Okay,
Yeah.
great, thanks.
Totally
Guido.
agree with that.
Yeah.
It's about administration and it's about daring things. Like, for example, in Germany, we have KENFO. It's a 24 billion fund to take care of the Endlager, the deep final storage. We have that now, so we could use part of that to build transmutation plants. It's just an idea, and we have launched that idea, obviously, with the ministries, but it takes an awful lot of time. So speeding up administrative processes is, I think, the #1 reason why we're lagging behind.
Okay.
Big
Francesco,
time.
you have the last word.
Great points. Celebration of deployment, of commercial activity, which means understanding of how IP needs to be worked on between national labs and startups. I think there is a big cultural hurdle. We can do this. This can happen within a year if we really want it. And then quick plug-in. We need things like the 28th regime. We need the Capital Markets Union. We need these things that let things actually grow, because we're very good at the starting points. We have to actually rise.
Okay, thank you. So two key takeaways from this panel. One is that we have incredibly innovative next-gen energy companies here in Europe. And #2 is that we're going to need all of these technologies to be able to meet our energy needs. So with that, please give a nice round of applause to our panelists.
Thanks.
Thank you.